We do have a pretty big vision of where we think the cloud is going to go, but we see three big challenges. The cloud is going to be functional for the way we see people need to use it going forward. It needs to be federated, automated clientware. That's a pretty darn good promise.
In terms of how do I embrace the cloud for my mission critical and compliance workloads, today you really have to make sure that you can adequately show you have the right controls for everything from provisioning and resource allocations to security, and making sure that you can adequately monitor and log and track everything that's going on.
When you're in a multi-tenanted environment, right, security is a huge red flag.
You're doing billing and chargeback based on what you're consuming on the cloud. Clearly you need to be able to protect that infrastructure.
We have to address a multitude of issues. It's not just a new Web 2.0 application which scales out and has availability built in at the application layer. It's all about running these legacy enterprise applications in a secure, high-performance environment. The core of our platform is the Intel chipset, the Xeon processor chipset.
We've always used Intel Core, Intel Xeon processors. That's been the core of our architecture from day one.
The virtualization instruction sets that Intel has incorporated into the processors, really allow us to leverage and provide those guarantees of performance. Things such as the TXT, the Trusted Execution Technology.
We can detect the trust level using Intel Xeon E7 processor family based on TXT, whether the hardware and the hypervisor is known and trusted and has not been compromised, and make sure that workloads are only allowed to be powered on trusted hardware all the way through to the hypervisor itself.
My name is Brian Kirsch. I'm with Children's Hospital of Wisconsin. We're currently a Intel Xeon processor family. Xeon Nehalem architecture allowed us a very high density of cores where we could have a dual 3, 4 vCPU virtual machine while still maintaining a 20 to 25 virtual machines per host density. So we're here to treat the children. We're not here to build data centers. So the Xeon chips give us that density to fit it in a smaller form factor and give us the horsepower to actually push these applications out with the low latency for the critical times that we need.
Intel's continue to take a lot of their RAS functionality, that's reliability, availability, and serviceability, and take that from their Titanium architectures and push that down into x86. And every time we see a new processor generation, we continue to see benefits in terms of bit error corrections, in terms of memory features, where our boxes, which are now handling more and more load, more and more virtual machines, more and more compute, aren't going to be as affected if there is an error.
The probability that you end up having uncorrectable memory errors is increasing, just because the memory is increasing. And here comes MCA architecture.
Machine check error recovery. What would happen is the hypervisor would identify with which VM that memory error that you cannot correct because there's 3 bits or more that are failed, which VM is that memory associated. And instead of bringing down the whole system, we basically killed that one VM, and the hypervisor and the other VMs continue running.
To be able to provide the encryption and all of the policies around launch control and access control are absolutely critical, and the Intel features that they've built into the Xeon chipset have really enabled that and made it possible for us to provide enterprise mission critical application services for our customers.